Everybody. Today we're happy to host our third and final installment in this month's three-part series about Databricks and how it's used out here in the real world. In case you missed the prior ones in the series, we'll be putting some links into the chat here. But the first installment was a riveting discussion with a long-term Databricks customer, and he talked a lot about how Databricks helped them advance their corporate goals. Our second one was a discussion among some of our senior consultants talking about how to optimize Databricks for both performance and cost while adhering to best practices. And then today we're going to be talking about how Databricks can augment your existing data strategy with AI. So my name is Patrick Vinton. I'm the Chief Technology Officer here at Analytics 8. I'll be moderating today's discussion. I'm happy to be joined this morning today by Tristan Nixon.
Yeah. Hi, everybody. My name's Tristan. I'm a specialist solutions architect at Databricks, focusing on all things AI and machine learning on our platform. I've been here at Databricks for about 5 years, but a long career in data engineering, data science before that.
Cool. So we're in good hands today. Looking forward to the conversation. So when we think about AI and specifically the strategy, there's a lot of things to consider. You got your use cases, you got government, how does it fit in with the rest of your data strategy? I mean, those are definitely items that need to be considered when you want to think about AI and want to have success when you roll things out. But today we're going to be kind of focusing more on the technical aspects of AI and the strategy and how Databricks can help advance those. So with that mindset, when I think about how AI fits in, I kind of think about the challenges that maybe you and I have seen over the years with customers who struggle to get stuff from kind of an idea in somebody's head out all the way to production. And when I think about those things, it really kind of boils down to four main categories. It's the data that you're going to be using, and all things around that, just the data, the types of data, the governance, how you're going to keep it how you're going to keep it current. It's building the model, whatever the model is, what languages are you going to use, what tools you're going to have them do it, what environments they're going to build in. Think about the ops. So thinking about like change management and then how do you go from dev to test to production and overall change management. And then also like related to ops, like how do you collaborate with users, like the people that are actually going to be using that, people that are going to be creating, consuming the fruits of this labor. And the last thing is once you've launched, how's post-launch scalability? Does that make sense, Tristan? I mean, that's kind of how I think about from a technical angle on AI and strategy. Does those categories make sense to you?
Yeah, absolutely. I mean, in a lot of ways, this isn't that different from more traditional data applications. It's just, the AI adds a certain intensity to the data operations in a lot of ways. But yeah, absolutely. That sort of end-to-end life cycle from, sourcing the data, getting it all cleaned and governed and managed through to development, deploying those applications, and then, scaling and monitoring the applications in production. And one of the goals, that we've had in the design of the platform and the services we provide around machine learning and AI is to have components at all of those stages to make that process as seamless as possible and allow all the different roles to connect to the platform and do their work and communicate with each other through the platform.
Cool, that makes sense. Yeah, and that's one of the things that struck me as I've been working with Databricks in recent years is how it's not that much different than what you would be doing with traditional analytics. And when we talk about AI, like we use kind of AI as shorthand here, you and I, during this conversation, but we really mean all types of advanced analytics, AI, machine learning, anything that requires some sort of model. So let's go to the data real quick. How does Databricks tell me about how Databricks as a platform can expose data and different types of data for various types of models there? How does Databricks do that? And how can you think about that?
I mean, it's been a goal of ours for a long time to kind of unify both the structured and unstructured data into a single kind of coherent platform. If you think about if you go back a number of years, that you had a lot of data states that were very siloed. You'd have sort of data warehouses where everything, all the structured data was very well curated and organized. And then you'd often have these very chaotic and unstructured data lakes for everything else, everything that fell outside of that framework. And, of course, the the refrain being that those would often turn into data swamps where you couldn't find anything and you couldn't test the quality of anything. But our goal, a few years ago, we pioneered the concept of the lake house being, a single platform where you could bring in all the various types of data, regardless of whether they're structured, unstructured, and apply the same kinds of high quality data governance and management principles that you would use in a data warehouse, but use on top of kind of commodity data lake type storage platform, right? So that was really the kind of the lake house concept. On top of that, or in that space, we've pioneered a number of things. We've got, our Delta Live tables, which allow you to do, serverless and declarative data pipelines so that it makes it very easy to set up complex data pipelines that ingest data of all different formats and at all different scales, right? So that's sort of, just the data engineering space, bringing all that, the different varieties of data in and bringing it up to different levels of quality. Then when we think about like, how do we make that available? The Unity catalog, allows for the sort of the discoverability and the governance of all of those varieties of data across, multiple different data clouds, and because you can unify data in different clouds and different accounts. Um, and then, there's things like our feature tables, which allow you to organize data into specific features that, you can share with data science teams or make them available for inference and whatnot. So there's a number of different features there to sort of help manage that problem.
Cool. So a lot of features and a lot of good stuff there. Thanks for that. But to take a step back, basically what I'm hearing is all of the work that you would be doing or maybe have already done for traditional analytics with structured analytics, you get to basically leverage that. And if you use Databricks as your platform for AI and advanced analytics, you've already done a lot of the work already. Am I correct in saying that?
Yeah, absolutely. I mean, the platform for a long time has been a good one for data science because we support other languages, beyond, just this sort of SQL you would expect from a BI type or data warehouse type platform. We also support Python, R, even Scala, of course, was the going back to the origins of Apache Spark, languages like Scala and Java. But Python being the kind of the go-to language for data science and all of the different frameworks and that are available for that. So you can build, and our machine learning runtime comes prepackaged with all of the major machine learning and AI toolkits that you would want to begin developing that. So it's very easy to just sort of access the data that's already been, prepared and curated in the data lake, and then begin building models on top of the platform.
Got it. Yeah, I mean that super helpful. That last bit that you talked about was kind of the second point I was talking about is when I think about the challenges that customers have had, one of the things they have when they're trying to plan for it, and sometimes they get stuck and they get hamstrung because they're thinking, well, I don't know what I want to build, and I don't, I've got some data scientists that want to use this, and I've got like some kind of more citizen data scientist that wants to use that. You kind of already talked about that where pretty much you can satisfy all the types of advanced users for this because it comes kind of native in the box. I think another important thing to point out though is unlike traditional data scientist workloads is you're not having to get them like this giant beefy laptops. They can run all those workloads locally. They can program in all these familiar languages, familiar paradigms, but they're getting to leverage the power of all the compute and horsepower and storage in the cloud.
Yeah, I mean, the nice thing is, it's very easy to spin up, a whole range of resources in the cloud, whatever, you can enable in your cloud account from, a range of different types of CPU-based VMs to much larger GPU VMs and, setting up clusters that, you can distribute that work across, large clusters. So the scalability is there for, even the most intense workloads, we have customers that process petabytes of data in through their machine learning models on a regular basis.
Got it. Cool. I would like to go back to the first point on the data. I think we kind of spoke pretty well to the second point. Actually, no, I'm going to contradict myself here. Some of the conversations I have with customers were like, all right, I'm considering investing in tool X. or maybe this tool Y over here, and that's going to be like our foundation for advanced analytics or for AI. And one of the things I want to caution them is like, yeah, there's a lot of good, like very specific point tools there, but you're programming and you're developing within their paradigm, within their model, within their approach, I should say. Um, and so, you're kind of, in many ways, you're stuck with that one point solution. It's often a proprietary language, it's a proprietary platform. It means you're gonna have to like replicate data to that platform, perhaps. Um, it means you kind of got some vendor lock-in as well. Whereas, if we talk about the first 2 points that I talked about, what languages are you going to be programming in? How are you going to be using it in the data? You're not painted into a corner with that. You have, and so when I think of conversations I've had with customers are like, well, I don't know where to start. I realize some of this may be throwaway. We may change things later, swap things out because technology is changing so fast. I'm like, cool. If you recognize that and you need to be comfortable with that, why would you invest in something where you're going to be more susceptible to vendor lock-in? So I think that's a really cool point, and why I think Databricks really does help. It seems to be a very safe bet when we talk about AI, and augmenting your strategy with AI. All right, let's go back to the data for a second. You talked real briefly about Unity Catalog. For those, I see some folks in the audience here that may not be super familiar with that. Can you talk about that and why that's important?
Yeah, absolutely. I mean, we recognized a number of years ago that, the issue of like governance and management, of resources in a data lake or in the cloud is one of the key things that a lot of customers were struggling with. And there wasn't a really good solution that would span across multiple platforms, multiple instances. And so the design of Unity Catalog from the beginning was to be really like a single catalog type system where you can bring in all different types of objects, not just data tables, but also things like machine learning models, reports, other types of assets and resources, even just like file systems or in the cloud, buckets, for unstructured data. And they can all be managed through this standard sort of grant revoke type SQL syntax that any data warehouse, admin is familiar with. Um, and also, again, unify across multiple things. So you can federate out to different types of data systems. You can have them, different data systems federated into the Unity catalog. It can span across multiple accounts in the cloud. So it really becomes a single point where you can apply all of that management and governance. And it also allows for a lot of discoverability because, of course, once everything's in that single catalog, all the different users can search for the data resources or assets that they might be interested in. There's a whole lineage system in there. So you can see, if a machine learning model is there, you can see, there'll be connections to what was the data it was trained on. And a lot of metadata around all of these assets and resources is in there as well. And one of the interesting things is we've connected the whole thing up with some generative AI in our platform. So you can have generative AI actually automatically generate some of the metadata you might like. So for example, it'll look at the structure of a table and suggest things like descriptions and for the fields and whatnot.
Cool, very cool. One of the things you talked about there that I thought was interesting, was talked about different types of data systems. So we've talked about, and often we think about Databricks as like, all right, it can handle these types of workloads, uh, data lakehouse type workloads. But one of the cool things that I haven't seen in any other platform, which is just super cool to me, and it's a big sticking point, is is something like the vectorization, and vector databases. And so let me take a step up a few levels for those and those. So when we hear about generative AI in these models, we know, just casually reading about it, we know they have it trained on a great deal of general knowledge. And that's great. And that's what makes them feel kind of human-ish when we interact with them. but that's only so valuable. Where it becomes really valuable, especially in the corporate workplace, is when you are able to inject knowledge that's proprietary to your organization, that the model would otherwise have no idea what it is. There's a couple options there. One, which is quickly going out of style because it's kind of not necessary, especially for what we're about to talk about here, is you train a new model and give it access to that, and then it has that general knowledge. What is more commonplace, and I think it will be common, I think it will be increasingly more common, is you use something that's called RAG. Today it's called RAG, tomorrow it'll be something else. And RAG stands for Retrieval Augmented Generation. And what that is, that's a fancy way of saying I've got this LLM or this model that has this general knowledge, and I want to augment it at runtime with at query time with my proprietary knowledge. And the way you do that is you ask a question, what's going on behind the scenes, like when you go to a lot of these things, if you have something that has access to this, is you ask the bot a question or you give it a command. What it does is it looks at your proprietary information and injects that into the query and then sends that to the LLM. So with that in mind, the most common way of doing that today is use what's called a vector database. That is basically the window into your organization's rich proprietary knowledge. So far, so good, Tristan. Did I say that correctly? You're the
Absolutely.
okay, cool. So knowing that that's the common way today, and it needs to be fast and scalable and big and something that's going to go across all your data. Tell me a little bit about how Databricks solves that problem of, we've got all the source data here, but we've got to have a window into it using vector databases, at least as one option.
Yeah, absolutely. No, you're spot on there. I mean, it's, making that a lot of that unstructured data, particularly mostly it's text, but you can also do this with images and other types of data, but making that searchable and accessible so that you can find the most relevant information for a particular query and do that quickly. That's really where these vector databases really come in. And so one of the things we've done is we've created, I mean, there are a number of different vector database services out there. But we want to make it really easy for users to set one up within our platform. So we actually have our own vector database or vector index service. So any table that you have that's already in Unity catalog, you can just with a few clicks create an index on that, and there's some customization in there in terms of like the type of model that is used to generate these vector the embeddings. There we have a couple that are available out of the box. You can also provide your own if you have a custom model that you want to use. And then you can also decide whether or not you want our platform to manage the generation of those indexes, or you're going to do that yourself. You can actually have custom code that will generate the embedding column, and then we'll just index that. But basically it allows you to really rapidly create one of these searchable indexes that can then be provided as a standalone service so that other apps and devices can query that index, or it can be embedded into a deployed AI model when you deploy it on our platform. So it'll just natively have that searchable capability embedded into it.
Cool. And I can tell you firsthand, having developed a couple AI apps and overseen some of those projects, that's a really hard part. Like it's kind of easy to get the bot doing something that's conversational, but getting it to interact with your intellectual property that's a hard part. And it's a hard part to scale. It's a hard part to tune. Another thing that you kind of glossed over that I really want to point out is because it's right there within Databricks, none of this data is ever leaving your tenant. So you're right, there are other vector solutions out there, but a lot of them require you to have a lot of your potentially sensitive information leave your environment. And that's something that we don't want to have. And in many industries, that's not even legal for that to happen.
Yeah,
And
absolutely.
yeah, even whether it's the data itself or it's metadata about the data, that it's still leaving your environment, and you don't want to get in a regulatory situation where you're having to try to explain to some attorney like why the metadata doesn't matter. So it's all right there, and it really is just a few mouse clicks away. Super powerful and fast, and it really expedites development. One other thing that you kind of glossed over, but when that was actually news to me when you mentioned it, which was we're not just talking about like unstructured text data or in structured. We're actually talking about binary data like images and audio. Um, and I guess that makes sense because it's just there in your data lakehouse. Like it's just another piece of data. So it's yet another example that I hadn't considered where if the data is already there, you can just use it. So that's
Yeah, yeah. I mean, one of the nice things is that once, if you have an appropriate model that can generate these what are called embeddings, is basically a way of converting some unstructured data into a sort of a simple summary in a numeric form, then the indexing problem is very much the same, right? So, the nice thing is that, you can bring in, maybe it's an open source model from Hugging Face or one that you've custom tuned on your own data, and you can use that to drive, the indexing for, custom data source like that.
sure, sure. Cool. All right. So we've talked about how it is to get started, and there's a lot of options that are available. And then we've already talked a little bit about how we're no longer in a situation where, you have to give a data scientist this giant beefy computer and with a whole lot of process compute and giant hard drive where you can have that, pull that down. And besides the fact that it's a pain, it's a little bit should be frightening to people that there's data that's leaving their tenant to somebody's local. But so we've already kind of got past that. Let's talk about some of the other operational challenges when moving an advanced analytic project from development to test to prod. Tell me a little bit about the change management, and if you can, kind of for sure the technical pieces because that's part of ops, but also talk about opportunities where Databricks allows you to collaborate with perhaps less technical users who are definitely part of the equation when getting something launched.
Yeah, absolutely. No, that all of those things are, come into play, and like I said, we've tried to design the platform around, bringing all of these different roles together and allowing them to work as seamlessly as possible. So, for a long time, we've had one of the core pillars of the platform has been this tool set called ML Flow, which is largely based around, allowing the giving tracking capabilities to data scientists. So as they're developing their models, all of the experiments that they're running and different variations of model testing and evaluation can all be tracked and stored basically it's like it's stored in a database that's searchable. So you have the whole history of all of those different experiments just there and visible, including all the performance characteristics of the different variations of the models. Then when you think about, okay, we have a candidate model now that we want to then move into production, that handoff from the data science team that might be developing it to, whoever the deployment engineers or ML engineers who are going to be deploying that model, can be a little bit tricky. So one of the nice things is within ML Flow and Unity Catalog is you can register a model into, very easily from, an experiment, one of the runs that you've done in ML Flow into the Unity catalog. And now it's a managed asset within the Unity catalog where all the permissions and governance can apply. And again, that lineage allows you to quickly go back if you're looking at a particular resource, model or artifact in Unity catalog, you can go back to the ML Flow tracking thing and you can see all of the work that was done to develop that model. So if you need to go back and inspect how it was built. But then, within the Unity catalog, there's a versioning system for models. So as you're thinking about moving from version 2 to version 3 of a particular model, you can put them in there. You can apply these deployment tags, which allow you to say, okay, this is the one that's currently staged for production. This other one is now in staging, and from there, it makes it very easy to pull those models into the different environments and run the appropriate tests or workloads from them that way.
Cool, super cool. Yeah, you did that's super helpful talking about how we can do versioning of models and keep all that stuff track. Uh, you may be too used to this now, but I've seen too many recent, I've had too many recent conversations with customers that are trying to do stuff, not going with a different approach. Or like, I've got this model. How do I literally, how do I hand it off to somebody else to use or to test and stuff like that? So, you
You
talk.
you have no idea how many customers I've seen doing all of this and with like emailing Excel spreadsheets to each other. It's just it's not a scalable solution.
No, well. yeah, or giant pieces of code, and then with all the required libraries and stuff like that. But that's kind of the more that's obviously an extremely technical thing we're talking about that's reserved for a handful of data scientists. But I actually see somebody in attendance here that I had a conversation with recently, a customer of ours. And one of the challenges that she had was I've got this model and I've got these really talented data scientists. They built a model and they've got it working, but like the business users were looking at the results of the model and they were working with it together, very, very typical part of acceptance testing. They said, it feels like the test data was not correct. Maybe the assumptions were correct. We want to give you a new version of test data to do with that. And what had occurred to me is using ML flow and the things that we talked about. It provides a real easy way for somebody who's not a data scientist to collaborate and be part of the launch process. Like, you know what? I'm going to curate a new set of test data for you. Let's run it against this. And there's versioning and stuff of that too. And that absolutely blew my mind when I saw, because that when we talk about challenges that we've heard over the decades of watching these things, that's another really, really huge one.
Yeah, absolutely. Yeah, no, I mean all of the data in the data lake can be versioned, right? So you can absolutely have different versions of the training data and the test data as well. One of the other things I think that's really a really useful component for this kind of handoff or the evaluation, internal evaluation with, say, business stakeholders, is we have, these thing we call AI Playground. And the nice thing about that is it makes it really easy to come in and start chatting, for example, with some of the foundation models like the Llama models, but also any other apps that you've developed internally. Once they're deployed to an endpoint, they can be, a user can pull that up in the AI Playground, or there's an evaluation suite, and they can chat and interact with that, and then also flag interactions and make comments on it, and all of that feedback can go back to the data science team.
Perfect. Perfect. So, one other thing, and this is kind of like as we come up here on time, we're going to talk about scalability and some of the post-launch stuff here. Again, not specific to advanced analytics, but to kind of any sort of R&D. I'm not even just talking traditional analytics, but any sort of R&D. You in a perfect world, you would have something where you could move quickly, potentially fail quickly, and you're not having to worry about provisioning something to the moon and then trying to work through that. And you're not trying to have to over-engineer things up front. If you develop using cloud native resources, you can build this and then just scale it as you go if there's a success. And you can be really nimble and move really, really quickly. So that's something that I want to make sure that people understand when we talk about this as well, that in case it's not obvious. When we think about the kind of the old way of doing these things, that we kind of had to do some of these things at first. We kind of did have to over-engineer and overbuild them just in case they were successful. So let's turn the corner now. So we've got through things, we've done all these ops, we've got good things. We've collabed with the end users, we've got all our data, we've launched. Now we go to prod. I think this is an nice, easy one to end on for everybody. Like how can we be comfortable that once we've launched something that it's going to be to scale, it's going to be performant with 100 users hitting it rather than the 1 or 2 users that have been hitting it for the past month?
Yeah, well, one of the nice things with when you deploy models using our model serving infrastructure, those are very scalable. You have there's a number of sort of deployment sizes that are available, from very small ones that are appropriate for just for testing, all the way up to large ones, and they will auto scale up and down. And you can even have them scale to zero if you have large periods where there's going to be no activity. They will scale down to zero, so you're not paying anything when they're not running. Then they will scale up, and they can scale to very large workloads. There's a number of sort of sizes that are available out of the box for certain customers who've had larger workloads even than what's sort of available. We have a technical team that can enable even larger instances beyond that, for really, really large workloads. And the nice thing is that you have the choice of both CPU and GPU. So for some of these really GPU intensive things with some of the large language models or other types of large models, you can access GPU instances for those serving endpoints as well. And then, to sort of complete the loop, one of the other capabilities in the platform is, all of these deployment endpoints, you can enable what are called inference tables, where all of the interactions, the inferences that are being generated from that model, whether it's, a language model or one of these complex like RAG applications, or even, just a classic ML model where you're generating numerical predictions, all of those are stored into an inference table, and then that can drive analytics on the results. So you can track the progress of the model and whether the results are staying within expectations or shifting or deviating from norm.
Very, very good. Well, awesome. That was super interesting. Just I enjoyed the convo, especially before you probably finished your first cup of coffee. Thanks again for joining us, and thanks everybody on else who joined us. If you'd like to contact me, it looks like we got contact info dropped in the chat, and also we will be sending out recordings and a link to the recordings after here shortly. So thanks everybody for their time. Thanks, Tristan. Everybody have a great day.
Talk to you.